Hello, good morning.
Francis, GM.
Good morning.
We
We are,
actually,
mhm.
we're actually gonna have a couple people joining from my screen because we're doing like an engineering offsite, but we're a startup, so that means we're having a LAN party at my place.
That's very cute.
My goodness.
Hello. All right, we're definitely waiting for more people to join us. Let me
Love the
send them
party.
a ping.
Where are you right now?
We're in Portland. We're having the County Labs engineering offsite at my living room.
Nice. That's amazing.
All right, I'm going to ping people. Oh, never mind. Okay, looks like I need to play tech support. Oh,
Francis, can you see my screen being shared?
yes, I do.
Yeah, now we could see it.
Amazing.
Should I change my name on here to say County Labs instead of Alex Con?
It's okay. I-
Hey, Aline. Hey, Aaron.
Hey guys, how are you?
Doing all right.
Hey,
We're having a
at
LAN
least you
party.
again.
Aaron, you're in Texas, is that right?
Me?
Yeah, where are you at right now?
I'm in Mexico right now.
Oh, okay. Kind of
How about
close.
you?
We're in Portland. We are having
Oh.
our engineering offsite, but we're a startup, so that means we're having a LAN party in my living room.
Yeah, buy some tax-free goods.
Wait, that's what you're doing in Mexico? Oh, in Portland. Yeah, no sales tax.
Yeah.
Yeah, that's why they're here, to buy tax-free goods. That's actually the entire reason. We're just doing,
a good idea,
we're just doing legal arbitrage.
Um, all right. Sorry, y'all. This is our first time doing it through Zoom. And I guess people are not logged in.
Yeah, no, there's a problem even if you're logged in.
Really?
Yeah, I was logged in.
Yeah, I spent some time. You need to fill the form first, and then I have to use Zoom again, which I haven't used for a while. Then there's a SSO, like authentication.
Yeah, this time there's a requirement. Typically, you could do it without being logged in.
Mm,
So I think that on our end, I made sure we all filled out that form that got us added to every recurring AIP meeting, but we did have to like authenticate through that form. So I'm guessing that if people just have the Zoom link, that they won't be able to without some maybe overhead. I'm guessing it was to prevent Zoom bombers.
yeah.
Yep. That's what happens when you get permissionless systems.
Okay.
We need
Sorry.
Zoom Sybil resistance.
Yeah, I mean, that's what the password is for. So I guess we kind of figured it out.
Yeah, I guess I don't see like a way to bypass it, and I'm not allowed to like edit the actual meeting since it already started.
Yeah, but typically with Zoom, you can send around a meeting link with the password encoded in the link. So as long as they have the secret link, they can get in. But
Oh, that's right.
Yeah, that's what I have shared,
Yeah, that's
but
what I tried to use and it didn't work.
mm,
You'll have to register and log in even though I was signed in.
oh no.
Yeah.
Like I literally clicked join from the Zoom workplace app and it took me to the registration page.
Aaron, are you in Mexico to get tax-free goods?
I pay Mexican tax.
Say what?
I have to pay tax here. I
Okay.
mean, the tax is like 17%. I don't know. Sales tax. Yeah. The taco is like $1.
There you go.
Pretty sure this meeting's not about this, but I'm pretty pumped about that BlackRock announcement. That was sweet.
They announced, and I'm assuming they announced an Aptos ETF. Is that what this is?
It was BIDL, or it's like build
Oh, okay.
the BlackRock initiative. They're like, yeah, it was announced it's like a couple hours ago. It says
It'll-
BlackRock, the world's largest asset manager, has announced that BlackRock USD Institutional Digital Liquidity Fund. So that's what that stands for. BlackRock USD Institutional Digital Liquidity Fund is tokenized by Securitize,
Huh.
has landed on Aptos, the best blockchain for institutional finance. Pretty cool.
Oh, sorry, I was talking to myself. So we have our moderator here. We're a little bit over, so I'm not gonna do the warm opening this time around. I'll quickly go over the agenda so we can get started. Sounds good? So today we have two presentations. The first one is going to be AIP 103 permission signer. Rintian will be presenting it, moderated by Igor. We also have AIP 104 account abstraction, which will be presented by Aaron, and then moderated by either Igor or David if he manages to join in time. Just a reminder for all of the external attendees that this meeting is recorded. And we may choose to use clips from this meeting for our Twitter and on YouTube, things like that. So if you don't feel comfortable being recorded, please feel free to drop now. With that, I'll hand it over to Runtian. For those of you that have questions, since we're a little bit short on time with two presenters, please utilize the chat function to ask questions and then hold them till the end of the presentation so we can have a facilitated Q&A. All right,
All
take it away.
right. Can you hear me? Cool. All right. So today I'm going to present the AIP permission signer. So the quick recap of the problem statement is that signer is way too powerful of a construct in the current Aptos framework. So for people who write move code a lot, like signer is basically the struct that represents the user's intention, and then like it will get passed like all the way across the code stack, and it will be used to represent that the user is actually authenticating to perform actions, to perform actions. So in some sense, it's kind of like the sender in the Ethereum sense, but it's also used to basically like authenticate the user's operation. However, like the problem is that like it's actually like a bit hard for users to understand like what actually has been authenticated for a transaction. So basically like a signer is somehow like a wildcard to do capability that can be used to perform any operations on this user's behalf, like calling like any smart contracts. And if like basically, and particularly given the fact that like signers can be passed around, like this can be a particular bigger challenge to the security of the ecosystem in general, because like when you want to call like a smart contract, you probably need to pass a signer in to represent that, hey, like I'm authenticating this smart contract to do the following operations. But the core smart contract can actually pass the signers around and do other things that might not be the original intention of the users. For example, like withdraw extra funds or like buy some like random coin that like the user doesn't want. So it is not good. So like we wanted to expand the to have like a tighter constraints on the signers such that like the users get to control what can be done by passing the signer out. However, there's one major challenge here, which is like the solution here really needs to be fully compatible with all existing on-chain modules. Because if we said like, hey, signer is not safe, I think like the solution that we want to come up should be benefiting all the existing on-chain modules that are currently utilizing signers for authentications. So in terms of like the actions required, we've already implemented all the proposed changes. We wanted to get some community feedbacks for this feature, and like right now the feature is only like hub friend, so that like it only allows permissions to be set for it only defines a couple of frameworks level permissions, but it's not yet open to any third parties. But we are looking into like if the developers are interested in like setting up their own permissions, like let us know so that like we can see like whether the API that we're providing makes sense or not. So high level summary. So in this AIP, we will be changing the representation of signers in the VM so that like it can include some extra contextual information about the permissions. We also implemented a framework module to create and manage those contextual information and actually change the Aptos framework such that like all operations has a proper permissions required. So at the beginning, the permissions you should be expecting are like things like how many funds you can withdraw from this particular signer, how many which NFTs you will be able to operate for this signer. And there are a bunch of like other higher level categories of permissions, such as like, can you use the signer to participate staking, voting, like can you perform key rotation with the signer, etc., etc. So there's like a couple of permissions going to be designed in terms of the Aptos framework. From the timeline perspective, the PR is already implemented. We're still waiting for move to support so that like we can land those features with enum so that like we can evolve the code in the future. So like timeline wise, like we're looking into getting some feedbacks and reviews like this month, and like we will most likely land the changes mid next week. Sorry, mid like December-ish, and we will be landing those initial feature sets in, and then we'll be evolving and adding more features to it. So solutions, what are we actually implementing? So like we are replacing the existing signer representation in VM with an enum. So like right now, like signer is more or less just a wrapper around an address. Like we wanted to say that like instead of a simple wrapper around an address, it's now an enum. The first variant is like the master signer. It is the same as existing signer in the VM. So in that, from the permissions setup, like you can think of it as a sudo. It means a sudo permission. Like you will be able to execute anything, so that it's in some sense the semantics is exactly the same as our current system. The second variant is the interesting one. We call it like permission signer. It's a signer with contextual information. So basically you could imagine it being like a signer that contains both an address and also like a key value pair of where key is the permissions and the value, like the key is the type of permission and value is the permission itself. So that basically like you could imagine that like you can pass the signers around, but like when you try to perform some particular operations with that signer, if the code sees that it is a master signer, then it means that it is the original signer. Then like it won't it will by default have all those operations. However, if you're trying to perform things like a withdrawal on the permission signer, then like it will try to fetch the permission config in that context and see whether the context actually makes sense to you or not. By that, like users can, like you could imagine that like for a transaction, user can set up like users can set up like the permissions, say like how much APT you can withdraw with the signer, and then pass that particular signer to the smart contracts. All the core smart contract doesn't actually need to be changed, but only when it hits like fungible asset withdrawal, we will check whether the there's gonna be a permission check, checking whether the signer is a permission signer. If it is a permission signer, then like whether it has enough permission for you to withdraw that funds. So for the API, it looks like the following. We have a new struct called permission handle. By the way, can you see the, is this too small? Is the font too small? Like,
It's legible.
okay, cool. So like for the permission signer, we create a struct called permission handle. Like we will first create, the first API is like create permission handle. It takes in the master signer. So this is the signer that you are currently receiving, and it gives you a permission handle. From the permission handle, you can derive another signer. So for the difference here is that like this signer that's being derived is a permission signer, and you will be able to install various like permission configurations to the permission handle. And like in this flavor of API, like the permission handle is a hot potato type. It does not has store or drop ability, which means that like you will actually, it is a ephemeral like permission that is only being installed for the context of one transaction, and it needs to be destroyed after this transaction. There's also like a helper function saying if the signer we're taking in is actually like a permission signer or a master signer. Does everything make sense so far? Okay, cool. So yeah, so like note that like permission handle can be used to derive the permission signer, and like the variant here, the invariant here is that like the address of the derived signer is actually exactly the same as the address of the previous signer. So like in that sense, you're getting like a signer whose address is exactly the same, but the difference is that like now you have this extra configurations about permissions. So about the authorization and the checking process. So like the permission signer will have this API called authorize. It means that like the master signer can grant permissions to the permission signer. So right now, like the permissions that we're storing, like what's being stored in the context is like a key value pair. The key is actually like more or less like any type. So in that sense, you can think of it similarly to Borrow Global. The value is a simple utility 6. So which means the following. So like each smart contract can define its own permission key. It's a utility 6. So that like you can imagine like fungible assets will define the permission key to be like a struct that wraps a metadata. So that it can tells you like how much APT or how much USDC can be withdrawn from this signer. So one thing right now is that like the authorized, like the permission of a permission signer can only be granted by a master signer. So like only the so here like only a master signer can grant permissions to the permission signer. The two address need to be exactly the same, so that like you cannot grant something to someone else. And then there's a bunch of like check permissions helpers, which says like whether you can check whether a permission key exists, whether a permission key's capacity is above the threshold that you are setting, or whether like the permission key has enough threshold and you're going to deduce it from the stored utility 6. So how we're going to use it. So like the most critical operation is that like let's say like, for example, like a fungible asset withdrawal. So when you are trying to perform a fungible asset withdrawal, like we will check if there's actually like the withdrawal permission associated with that signer using this check permission consume actually. And like so let's say you are trying to withdraw 5 APT. like we actually need to see whether the signer that you're passing in is a permission signer. If it is a permission signer, then like you have to make sure that there's enough, at least like 5 APT permission over there. And once you withdraw it, you will need to deduce it from the permissions.
Is that stateful? Like does it mean
That is a
draw 5 APT again and again and again and again and again, or does it track how much APT you've withdrawn?
That is a very good question. So right now, like I think it needs to be stateful, because like otherwise, like you cannot set a total aggregatable limit. Yeah. So like another thing is that like right now, like the permission handle is not storable. So that like it's basically like a transient configuration that can be used by the leveraged by the dApp builder. So like imagining like people can write a script, like they like once they pass the master signer in, they can construct this privileged this condition sign this permission signer, where like the only permission we're gonna grant is that like withdraw 10 APT, for example. Then like you can pass this particular signer to the dApp and make sure that then like the dApp will make this mechanism will make sure that like the whichever smart contract you're calling to, and however many times the signer gets passed around, the entire lifespan of this signer can spend at most 10 APT from your accounts. So there's also like another flavor of this permission handle, which is the storable permission handle. So note that like the previous permission handle is actually like a hot potato, so it's actually can only be used once, and like it's like it cannot be stored. Like the storable permission handle is actually storable. So like in that sense, it's really similar to how we do key rotation capability. So we actually need to be very careful about that, because like it really means that like a user is storing it's like the smart contract that holds the storable permission handle can actually perform behaviors on your behalf. So this is pretty dangerous. So like we will probably only expose it for other framework use cases. And obviously for the storable variant, it needs to have an expiry time, so that like it cannot live forever, and like it needs to be revocable by the master signer. So like imagine that like a account can, like you as a user can create this object so that like this object can perform actions on your behalf. However, like you should be able to revoke this permission granting like whenever you want. So like in terms of like the different alternative solutions, like instead of like having each module to implement like each permissions themselves, we wanted to implement a centralized module to hold all permissions instead of so that like we can have like a single entry point for controlling those accesses. So for example, like right now, only the master signer can grant permissions to the handle, and no refill of those permissions is allowed. So like if you have a permission signer, like you cannot acquire more permissions in that sense. So like this is benefited from the fact that like we have this one single module called permission signer move that implements this entire checks, and every other move module is actually simply using that module to perform those checks. So that like the life cycle of those permissions is actually handled very tightly by that module. In terms of the risk, like we see that these permissions will be used very frequently in the future, because like it is actually fully backwards compatible, as I suggested at the beginning of the meeting. Like even the existing signer, if the existing smart contract that takes a signer can use permission signer to like to tighten down the control. So you could imagine that like for simple operations like P2P transfer, you can also do things like that. So like we really need to make it to be very efficient and make it like gas efficient, so that like it can be used like very frequently. So in terms of security concerns, I think like it is very crucial for us to review like whether the permission checks in the Aptos framework is actually exhaustive. Otherwise, like the permission signer can perform operations that escape the intention of the creation process. So like imagining that like you have you're passing it, like once you create a permission signer, you can actually like call different operations on top, right? Like let's say like if you are somehow able to perform the withdraw permissions, to perform the withdraw operation without actually checking the withdraw permissions, we are actually breaking the intention of this actual extra safety encapsulation here. So another thing is that the storable permission struct allows the owner of the struct to behave as if it's signed by the underlying address. So it's actually as dangerous as account delegation. So we really need to be cautious about the storable variants here. So backwards compatibility, I think like this is the main thing that like the main design goal is that like the changes here are actually fully compatible with all on-chain modules. So for example, a DeFi contract that calls into withdrawal will actually abort in the future when the pass-in signer does not have enough permission. So like this semantics can already happen without even having to upgrade the smart contract themselves, the DeFi smart contract themselves. And lastly, like we are building support for building up permissions in the wallet and SDK. So like so that like it can be used by the dApp builders. Future potential. So like I think like there are two main things that we're looking at. Like one, like obviously one is that like this will obviously like make the Aptos ecosystem safer because like you can now set up things like a scoped call where like during that scope like at most X amount of funds can be withdrawn. Also like there are two major use cases we're looking for. Like one is that like we are looking for permission signer plus AA. Like we like account abstraction, which means that like you want to store those permissions like in the storage, and like you want to set up rules on when the storage permission can be accessed as signer. This can give you things like session style access to Web3, because like then like you could imagine that like when you try to log into accounts, like the wallet can create a storable permission signer that's stored on chain. And then like within the upcoming, say like 1 hour, like when the session is active, like the wallet can actually like send transactions with that storable permission signer to perform access on your behalf. So it really gives you like a session like Web3, and this will be explained by Aaron shortly. So the second thing is permission signer plus programmable lock contracts gives you some sort of future contract. So basically like you can now offer things like I can give you the permission to withdraw APT from my accounts, and like it's so that it's tradable in the form of a smart contract. So I've written the AIP out and the implementations are also out. So looking forward to the feedback from the community. And that's it. Thank you. Hope I leave enough time for Aaron. Any last minute questions?
And to kind of add from the kind of user experience, if you think about from the wallet perspective, well, like when the transaction is being created, when the like in the future when you're using the permission signer, the user might be kind of made aware of these are the permissions that you're giving when you're signing a transaction. So, and for example, the app creates a request and asks for a wallet to sign. A user will be kind of able to know what it's doing, and if it's using in the future, once we kind of move to permission signer, in the future when you're using an unpermission signer, it can give a warning that potentially more actions can be performed than you expect.
Yeah.
Any questions?
Yeah. So to Alex's previous question, the permissions are indeed stateful. Like basically the permissions will be installed somewhere in the global storage to store like the aggregatable limits of the signer, and will be updated.
Thanks.
All right. With that, we'll transition over to Aaron. Can you share your screen? Aaron. Hello?
Give me 1 second. I think there's a privacy setting I have to change. Let me see. Give me 1 second.
Would you like me to share for you?
Sure. That's easier because I don't know. I have to change some privacy settings. All right. Hi, everyone. So yeah, let's talk about a kind of abstraction. It's AIP 104, and now it's pending approval. Next slide. So first, let me introduce the problem statement. So what's the problem we're solving now? So basically, the kind of abstraction here I'm discussing, it's aiming to enhance the kind of flexibility and the scalability, by enabling custom move-based authentication logic, instead of what we currently have, rigid native schemes. And why do we need that? So basically, from product perspective, I receive multiple requests from teams like Merkle Tree or Mizu Wallet. So their use case is like, okay, I want to do some customized logic to achieve something like a counter delegation. But now their only option is multi-sig v2 and or like signer capability with some customized smart contract, which is very hard to use for their needs because the logic is fixed. Also, there I think some functionalities they need maybe not satisfied by those framework. So they asked me like whether we can have a more flexible solution, which we both think okay maybe a concept abstraction is the best suitable solution for that because it allow like a fully customization by anything supported by Move. In the native authentication limits user experience, scalability, and advanced kind of functionalities, I say. Another use case maybe we want to support a new cryptographic schemes, but basically, if we want to support that right now, we have to add a native function, native REST authenticator, and then those supported, and then with a binary upgrade, which is very cumbersome. And if everything can be supported by Move, we can just use a Move module, and then people can specify a Move module to call and do the authentication by Move function. They can just publish any module and call that module, so it doesn't need any upgrades. That's very easy to use. Also, we all know like Ethereum has supported ERC for 3337 for a long time ago. And to support more like use cases like blind signing, as Rentia suggested, we need this a way to abstract our account model. So what are the assumptions we made? So basically, user have to manage security of the move authentication logic because now we delegate the authentication logic from our native like the REST implementation to user specified move function. So they have to be fully responsible for the move function. Of course, as a foundation, as the labs, basically we may provide some like a move function, like a widely used move function for people to choose at their authentication logic. But for those complicated logic, they have to implement their own. Also, the developers has to adopt the move expertise. Otherwise, if they have some security hole in their code, they will suffer the problems or issues. Also, we have like optimized the library address usability and gas constraints. I would discuss later, like we have a gas limit for those move function for security reasons. So we are trying to optimize this and to make it's more flexible for people to use. Next slide. So yeah, I think now we just talk a little bit about what is account abstraction. So basically, it's a feature that decouples account authentication from native cryptographic schemes, allowing users to define custom logic for authenticating transactions through move-based functions. And while Aptos needs A, as I discussed, there are some multiple people requesting, like there's some product needs from outside. Also internally, we need this functionality to build new features, for example, blind signing together with permission signing, which is presented by Ricky before. Also, the existing authentication mechanisms are restrictive and require native upgrades. As I said, also compare solutions such as Ethereum ERC 4337. They allow contract wallets and external paymasters for enhanced user experience, which Aptos seeks to match while leveraging its move-based architecture. Since we're a totally different chain, our solution will definitely be a little bit different, right? So we all know like Ethereum has ERC 4337. It implements a user operation pool, contract wallets, and external paymaster, but it adds a lot of complexity to the development because it doesn't want to change their infra. They want to do everything at the protocol layer, which make things a little bit complicated. And it needs also external support to support it because we all know it has bundlers. So basically you need a third party to do this AA transaction submission as a service. And in Aptos, we want to make everything simple to use. We don't want to go to like a third middleware or something like that. That's why our solution will be only focusing on authentication based on Move, and also make it as simple as possible for the users. Next slide. So what's in scope? Basically, it's just we need a new authenticator with move-based authentication, and also I will discuss like what's the resource and functionality design between infra and a smart contract. Also, I will give a diagram to show you what's basically authentication flow in this new scheme, in this new design. What's out of scope is first is authentication function module design. What I said is people have to be responsible for the module or function they use for authentication for this purpose. So they will be fully responsible for that. Of course, we will prepare some we will prepare some official modules for authentication. But for people who they have their customized functionality, they have to design by themselves. We don't have a guideline for that. Also, the concept of paymaster, which is to pay for gas on behalf of users in Ethereum, basically is not included in this design. We may explore this topic in the future if we see a need. And the timeline-wise, same as Rentia, we already finished the PR, but also because I use E now in Move 2, we have to wait for Move 2 first, and then I can land the PR. And the proper timeline is basically similar to permission signer. I hope we can finish that by the end of this year. Next slide. So what's the recommended solution here? The solution would be just we move authentication logic to Aptos VM by using dynamic dispatch, allowing accounts to authenticate the transactions using custom mode-based functions via a new authenticator, which is called abstraction authenticator. Why it is the recommended solution? First, the flexibility, support any cryptographic scheme or any customized authentication logic. Also, scalability-wise, decouples authentication from region native code, enabling future expansions, upgrades. So the user can just publish a new module code and use that immediately by just sending a transaction to change the move functions they're going to use for the authentication of some account. And also security level, basically use a robust audited dispatch mechanism already proven in the fungible asset standard. So we believe it's from the design perspective, it's kind of secure. So what can I share to support this solution is better than others? I would say Ethereum has a very good solution at the protocol layer, but it's very complicated. So Aptos needs to avoid this need for user operation pools, external paymaster, and the bounding logic. because these all require a lot of like third-party support. So we want, as I said, we want to make AI as simple as possible and efficient, since our gas fee is pretty low. Also, the dispatchable authentication mechanism is already proved in fungible asset. So basically, I think it's already secure enough and widely used in fungible asset standard. As you may know, the SDT, they will use that. And also, we have a rich transaction context. We provide a comprehensive transaction context, allowing authentication logic to leverage extension transaction data securely and efficiently, similar such as the transaction hash in the transaction next gas, chain ID, whatsoever. So basically, you can utilize those data in your move-based authentication logic to achieve any transaction-related authentication logic. Next slide. Yeah, so this is our alternative solution is what Ethereum does. I think we just think it's too complicated. That's why we want to build a simpler solution. Next slide. So that's the risk overview. What are the risks? Technically, it's a little bit hard for beginners to understand how it works and to make the right setup. So basically, we are going to work on that on SDK and like it's Explorer to make it a bit easier to make it easy to be adopted by the users. Also, business-wise, I think it's kind of need to go through a slow adoption because it doesn't have a lot of ready-made libraries. Strategic is so basically it's also may need a slow adoption because compared to Ethereum, we are pretty early. So why there are risks? Because it's just very early and we need to educate the users how to use that. And also due to the gas limit, I think some very complicated logic may not be achieved right now. We may explore future, like in the future, there'll be more possibilities we can solve this issue. So as I said, like we need to provide more libraries or templates for common authentication functions and also adjust gas limit dynamically. Maybe just improve the execution speed. That's why we can do more like logic in those functions. And also we need to work with the documentation team to offer detailed documentation and developer support programs. Next slide. The security concerns basically lies here. First, it's user. We need to educate the user because poorly implemented more functions could introduce vulnerabilities. Also, for example, the auth data I will discuss later. It doesn't incorporate the transaction digest. So basically, it's a very like a common mistake people will make as a beginner. And also the gas limit exploitation may be a problem because if we set this gas limit too high, we may suffer from denial of service attack. I will explain a little bit later. Next slide. Okay. So first, we will introduce a new authenticator, which is called account authenticator, as I described in this graph, in this screenshot. So it has two fields. The first one is account function info. So basically, if you are familiar with dispatchable functions, you will know this function info basically is just a function identifier. It's like the address, colon, module name, colon, function name. This specifies which function you will use for your AA authentication. So this is a function that we will call to run, and then if this function is executed correctly, we think, okay, this authentication is successful. And the auth data basically is a enum, as I described in the second screenshot. So basically, why it's a enum? Because we want to support upgradability. For now, it is just only have one version, right? The first is a signing message digest. So it is like the transaction hash. It is what you sign for a transaction when you submit it on chain, and we just put it here because we're provided to you automatically. then you can just verify this digest in your move function. And the second is the authenticator. Basically, you can think it as like a signature, or you can put it any your public key plus your signature together if you're a normal ED25519 signature scheme. Then what you do is in your move function, you can just first read the public key and read the signature, and then verify this signature is correct against this signing message digest with regard to your public key. Then if it's successful, you can think, now it's a very simple case that you use ED25519 in account abstraction. So this data would be included in the abstraction authenticator together with your raw transaction. So I think I will answer your question later. Next slide. And the function info signature would require so all the move function as I described specified in the function info would follow this this function signature. So basically all the move authentication function you specified must has two parameters. The first one would be account, which is the abstracted account signer. We will pass it to you. The second one is the authentication data, which I described before is a enum with two fields. And we will require you to return a signer. So a most simple case, as I said, for ED 25519 is, in this function, you get the auth data, right? And the auth data, and also you the auth data has two fields. The first one is the signing message digest. The second one is whatever, like your signature. And then you verify that, the signature matches this digest. And then you can directly return the signer, the counter signer I passed to you back as the result. So why I do this? Like I passing a signer required to return a signer, right? The problem is, as a permission signer, the signer may be a master. So the first signer I pass here is a master signer, is account. The first parameter is a master signer. But the signer you return can be either a master signer, or if you have some special logic, you can return a permission signer. The permission signer will have a permission attached to it. So later the return signer will be used as a final signer passed to the entry function. So if it's a permission signer, have some permission, for example, I only allow you to transfer or withdraw 5 APT from my account. So I can return a permission signer from this AA function. And then later this signer is a permission. It doesn't allow to transfer more than 5 APT from my account. That's why we do we have a input signer and an output signer. So in normal case, if you don't need a permission signer, you just return the first parameter I passed it to you. You just return that intact. You don't need to do any customization. You just do the authentication logic and then return the input to the as an output. All right, and then also we for basically for smart contractor to know whether you supported AA. Each account has a new resource, which is called a dispatchable authenticator under the account address. And here we can support multiple auth functions. So that's why it's a simple map. I think before we land that, I may change it to the native map implemented by Igor, which has a better performance. So basically here is it's a set. It has a list of function info we're gonna support for abstracted account authentication. So you can have as many as function info you want. So each function info can be used to authenticate your account, which give you more flexibility. Next slide. So yeah, this is the authentication flow. I will spend a little time explaining how it works. So first, for a normal account, for like a non-AA, so if for a normal account who doesn't support AA, we can the basic flow is first we verify the signature matches the authentication key. For example, if you are EDU25519, we just verify your public key, your signature, and your authentication key with the sending message of the transaction. And then if it matches, okay, then when we can get the authentication key, and what we do is in Prolog, we verify the authenticated key from your authenticator matches authentication key stored in your account resource. At this step, if it matches, we know, okay, the authentication process is finished successfully. We know you are the owner of this account. And then we will just run the user transaction payload with the signer of this account. That's a normal case. But for AA, what we do is a little bit different. We know we have the auth data, which is carried by the abstraction authenticator. And then in transaction validation, we call this dispatchable authentication function, which indirectly call the function you specified in the authenticator. Of course, we need to verify it matches the dispatchable authenticator under your account. And then we run this function with auth data you provided. And if it's running successfully, it will return signer. And then in the prolog, we don't do any check like verify auth key because now we go through another route. So we basically for authentication, we don't do anything in prolog. We just verify basically the authentication function is you called is the one that's stored on your account. And then we bypass this prolog and then we execute the user transaction payload with the signer returned from the dispatchable authentication function, your move function. And then we run the rest. So here, if it's a signer, as I said, if it's permission signer, it gets the permission. And it has a lot of limitation when we execute a user transaction payload. To be noted that this dispatchable authentication function has a gas limit, so it may out of gas in the validation process. So that's a limitation right now. We require the dispatchable authentication logic is kind of not that overcomplicated. Because the problem is like that. If there's a malicious user try to pretend to be a valid user, it may submit an AA transaction with some invalid auth data, and then we will run this in the transaction validation stage. But at this stage, we don't know whether this user is a valid user or invalid user. If it's invalid user, we cannot charge the valid users money for gas because it's fair, because we don't know that whether this transaction is sent by the real user or just a scammer. So we cannot charge that. We have to bear the cost of running this dispatchable authentication function for free. That's why we cannot give too much quota for this free running execution. If we give it too much, I think it may be a security service for DDoS. That's why the solution is to make it simple to give it a limit. Another way in my mind actually is to introduce a guarantor. Like if we can ensure someone will pay gas for this transaction, we can allow more complicated authentication functions. But that's a little bit complicated for now. Maybe we need a native gas fee payer to support that. So for now, we just we just want to set a limit for the dispatchable authentication function. Next slide. So the authentication flow is like that. So first, the transaction carries an abstraction authenticator with a raw transaction. Then the Rust authenticator will run and find, okay, it is a abstraction authenticator. So the native function is a no op. And we just, but the authentication will be set to none. And then when running prolog, if the authentication is none, it will bypass the authentication check. And so here it is wrong. So before the prolog, Aptos VM will check each sentence whether their account authenticator is abstraction authenticator. If it is yes, then Aptos VM will run the move auth function specified in the function info with the auth data provided, and then expect the signer to be returned. If any sentence auth function aborts, the authentication check for the whole transaction fails. And it's notice this function has a gas limit. So if it's OOG, the whole transaction fails too. And then later, when everything was executed successfully, we will run the user transaction body as usual with the signers just return, as I said, it may be it may be permission or it may be master signer. Next slide. So for testing, we do like end-to-end API testing, and we also have end-to-end testing with the permission signer as a demo in the company. Next slide. For backwards compatibility, I think A is an add-on feature, so it can also coexist with existing default authentication schemes. So it doesn't have any like backwards compatibility issue, but in the future, to support this, I think Wallet Explorers and SDKs may not immediately support A accounts right now, so we have to definitely upgrade that. Yeah, next slide. So the downstream impact is existing indexer may not be able to parse or display a specific data like the customer mode function. For now, maybe not an issue, but a bit later, if someone really needs this data, we may need to build the feature. Also, wallet and SDK need updates to recognize and interact with abstracted account, and also supporting like submitting transaction from those accounts. And also transaction tracking tools may misinterpret A transactions or fail to display customer authentication details. But we don't need to worry right now. I think for now, most users are basically DApps. So basically they are doing this everything like internally. Next slide. The future potential is first, as I discussed, we should provide audited reusable modules for common uses, cases like multi-sig, time-locked transaction, or dedicated permissions. Also, this reduces the developer overhead and ensures secure implementations. For users who just want to use those authentication mechanisms, they can just specify those more functions provided by us, and then they don't need to write their own modules. Also, we want to relax gas management. As I said, a possible solution would require a non-AFA pair, as I think Aline are discussing right now in the chat channel. Also, we need to develop a seamless integration with Wallet Explorers, and also we want to allow accounts to specify fine-grained permissions, which we already did for our demo internally to support invisible signer. We may release this as a separate product in the future, which is a combination of account abstraction and a permission signer. Next slide. So summary here, as I said, the current account models on Aptos are rigid, relying on native authentication mechanisms that limit flexibility. So this solution can relax this restriction and will support something like a multi-sig delegated permission or risk isolated accounts and make a customization not that challenging as before. The solution is just to introduce a new authenticator with dispatchable authentication logic to run move-based authentication. So the deadline to make a decision is by the end of this year. Next slide. And here's the references. As I said, I put the link to the discussion issue here. Someone already comments, like a Mocha trade. Also, there's a link to the AIP. Next slide. Yeah, thank you. That's all. Any questions besides what Aline asked in the chat channel? I think also Igor already answered your questions. It's pretty tricky because if there's a fee payer want to cover the gas cost, it cannot be an AA because they itself need to run a customized authentication function, which may be a DDoS problem.
You mentioned earlier in the presentation about it not going live on mainnet because you were awaiting move 2.
Mhm.
I under the impression that move 2 was actually just at the compiler level, like it allowed new source code features, but it sounds like you're saying that a new VM needs to roll out on mainnet as well.
So for
Not new
clarification
VMs.
for both of these, the move to move to basically has a new compiler which is compatible. It adds new features like enums and other things that requires move to be enabled. Move to is enabled on mainnet, so you can use it already. What we are talking about here is whether the framework itself is compiled by move to, which we'll do in the release in December. So within the framework, we are not yet using move to, and we'll roll that out sometime in December. So that's what we are waiting for all the user level things that's already there.
Got it. Okay, so if I'm understanding this right, the new opcodes are enabled on mainnet, and the Aptos framework is only using the V1 opcodes. So in order to do anything with move V2 in the framework, you need to recompile the entire Aptos framework in a release and then publish it on chain.
Yes, and because the framework is big and things, we are doing it very carefully.
Okay, got it. Thanks.
All right, awesome. If there are no additional questions, then I believe we can end. Thank you all so much for bearing with me as we work through some platform issues. I'll make sure that it's much smoother next time around, and hopefully we get even more attendees across Aptos and across the community members. Thank you all. See you next month.
Thanks, Francis.
Bye. Thank you.
Thank you.
Thank you. Bye.